All right, section 6.4. We're going to talk about a quadrilateral again, and this is also a parallelogram, but it's a special type of a parallelogram, and it's a rectangle. And you think, that's no big deal. I know all about rectangles. Well, do you?
No.
Okay.
I do. I studied them.
Good. So here's a rectangle right here. Actually, I said that, but is that really true? Do I know that's a rectangle?
No.
Don't know it's a rectangle. I don't even know it's a parallelogram, do I?
No.
Right? Kind of looks like one, right? Kind of looks like a rectangle, but I'm not positive that it is. I have to be told a few things, all right? Here's what the definition of a rectangle is, and I'm going to show it through the picture. Okay, I'm not going to write it down exactly word for word. I'm going to show it through the picture. A rectangle is this. It's a quadrilateral, which means what?
It has four sides.
Has four sides. It's a quadrilateral with all four angles are right angles, okay? Or 90 degrees, okay? So all four angles are right angles. So if I have a four-sided figure and all the angles are right angles, then it's a rectangle, okay? Now watch this. If it's a rectangle, that means the opposite angles are equal, right?
Yeah.
Do you see that? So if the opposite angles are equal, guess what it is? It's a parallelogram. That's right. Remember that? Or you could say the consecutive interior angles are supplementary. Okay, that also makes it a what? A rectangle. Or a parallelogram. So watch. If it's a parallelogram, all the stuff that's true about a parallelogram is also true about a rectangle. So that means, by definition, what's true about, by definition of a parallelogram, what's true about the top side and the bottom side right here?
They're equal.
By definition. I've said this 100 times. Let's get it right for once. Okay. It's parallel. By definition, they're parallel to each other. And we also know by a theorem that what else? Actually, let's finish this up. Let's do the other two sides. Okay, what's true about both pairs of opposite sides about their lengths? Their lengths. They're congruent. So that is equal to that, and that is equal to that. We already see that the opposite angles are equal, and we already see that the consecutive interior angles are supplementary. Okay? Does that make sense? Okay. Let's do this. Oh, this is pretty. No, it's green. It's green. This is for Eric. Easter? Green and purple's Easter. It's like, okay. Now watch this. Now here's something different about a rectangle. Now what do we know, first of all, what do we know about the diagonals of any parallelogram? They bisect each other. Thank you. Listen, please. They bisect each other, but this is a special type of a parallelogram. A rectangle is a special type of parallelogram. There's a couple things that are true about a rectangle that are not necessarily true about every single parallelogram. Okay? Well, one of the things is, by definition, that all the angles are right angles. That's not true about every parallelogram, is it? It's only true about a rectangle. There's something that's true about about the diagonals that's not necessarily true about every single parallelogram. Again, I hate for you to always go by this, but let's do it anyway. Let's just look at the two lengths of these diagonals. What does it maybe look like is true about these two diagonals? Yeah, they bisect each other because it's a parallelogram, so we already knew that. But it's a rectangle. Guess what's true about these diagonals? They are equal. Well, they're equal to each other. They do make four triangles. That's true. But so does any. So do any diagonals. But look what's true about the lengths of those diagonals.
Oh, they're equal.
They're equal to each other. I tell you what. Since I've got. Whoops. Let's. Why is it? Oh, did I group them all together? No. Why is it doing that? Okay, I think I know why. Watch this. Listen, please. Watch. Let's reflect it. Watch what I did. I copied this diagonal right here, and then I just flipped it. All right? Because what am I trying to do? Do you think? I'm trying to compare and look. Sure enough, look. It's the same length, isn't it? Okay. So this diagonal that I'm floating around right here is the same length as this one right here. Do you see it? Okay, so I just flipped it around. I didn't change the length of it, and it's the same exact length of this one. So guess what's true about the diagonals? The diagonals are equal. Let's write that one down, okay? So on a rectangle, the diagonals are congruent, or equal, however you want to say it. I kind of use it interchangeably. Some geometry teachers would freak out if they heard me say that, okay? But I don't really care. So the diagonals are congruent or the diagonals are equal to each other. All right, so that's pretty simple, isn't it? So now watch this. We also know that they bisect each other because it's a parallelogram. So this and this are equal, right? And so guess what? Right, this one and this one are equal, but since you're splitting the same exact length in two parts, into equal parts, guess what kind of tick mark I can put here? No?
Same one.
It's the same exact, oh, as well, T-O-O, right. All right, also. So look, all four of these segments right here, from this corner to this point, all four of those are exactly the same. Does that make sense why they are?
Yeah.
That's not true about every single parallelogram, but it's true about a rectangle, okay? Because look, both segments are exactly the same. For instance, let's make this up. Let's say that diagonal is 10. Well, what would this diagonal be equal to, right? This would be 10 as well because the diagonals are congruent, right? Now, it's a parallelogram, so what else do the diagonals do? They bisect each other, don't they? Okay. Well, they do intersect each other, but more specifically, they bisect. Bisect means they split each other into what? Two equal parts. Okay. Just intersecting doesn't mean that they go through each other and they don't necessarily. Okay. So watch this. If this is 10 and this is 10 and they're both being cut in half, guess what this side is? That's 5 and that's 5. This is also being split in half. So what's this? That's 5 and that's 5. Make sense? Okay, that's why all four of those are equal to each other. Got it? And that's basically it for a rectangle. Okay?
All it is.
All right, well, that's the only difference. Now remember, everything else that's true about a parallelogram, everything else that's true about a parallelogram is also true about a rectangle. So all that stuff, okay, the opposite angles are equal, the consecutive interiors or angles are supplementary, the opposite sides, both pairs of opposite sides are equal, all that good stuff. So we just added a couple extra things. What was the extra things? All angles are right angles, and the second thing is that the diagonals are congruent to each other. Okay?
Yeah.
Are you with me on that?
Yeah.
And that's really the only thing that's different about a rectangle. And that's it.
What we're doing today?
That's all we're doing today.
Now we have a
So we only
worksheet.
had 10 minutes.
Well,
We
now we
had
have
more than
7.
10 minutes.
You know what? Just for fun, let's do some stuff from the book instead of a worksheet today.
Fun!
Yeah, this is so much fun.
I heard it sit. I'm so excited.
You don't think that's fun? All right, so we'll call it. Here, this is what you're going to put at the top of your paper. You're going to put section 6.4.
Wait, we're doing stuff out
We're going to do it out of the book, yeah. And so we're going to do pages 422. And I'll be honest with you, the reason I'm giving you stuff from the book is because the copy machine's not working right, and I wasn't able to make copies. So this is your homework, okay? This is your homework for the weekend. Okay, write it down. Write it down, because usually I just give you a worksheet. Now you got to write it down.
Well, I don't have a book, mister.
I have a book for you, actually.
Ho ho!
Why are you doing
Doesn't
this
that make
Super
your
Bowl
day?
weekend?
Doesn't that make your day?
Really?
Nobody cares about the Super Bowl.
I do.
Football season's over.
It's Super Bowl, silly.
Nuh-uh, the Eagles are out.
Silly.
The Eagles are out of it, so this football season's over.
Excuse me. Sorry, I'm a Packers fan.
Man.
That's not fair.
Don't say that.
You got one good player.
Exactly.
I object to this.
There you go.
You object.
I object.
Well, objection is denied.
Oh.
Overrun, or what do they call it? What do they say? It's over. No, not sustained. Overruled. It's an overturn. Overruled. Right. Your objection is overruled. I don't know. Sorry. I haven't watched a courtroom movie in a while, so. So there you go. 10 to 19. 10 to 19. 26 to 31.
And
That's it.
then-
Yep.
Why do you need to